Woo! Now I've got a video for you on how to solve for the heat that is transferred into or out of an object. And the equation we are dealing with, Q, which is heat, equals mass, specific heat, change in temperature. Okay, so the sample problem, I like to take long baths, long hot baths, and before I had a hot tub, I would have to reheat the water because it would cool down, and it'd be an hour, and I'm like, oh, I want it warmer. So let's say my tub has cooled down to 100 degrees Fahrenheit, and I want it at 104 degrees Fahrenheit. How much heat is it going to take in order to heat that up? Well, I looked up a typical volume for a bathtub, and a typical volume for a bathtub is about 30 gallons of water. All right. Now, okay, that's not a mass, is it? In a lot of these problems, you're going to be given a volume and have to convert to a mass. Well, we actually have two conversions here. That's not metric. So let's convert this to liters first. That is 113.6 liters of water. And now the idea of density is what we're working with. How many kilograms is 1 liter of water? Well, the nice thing is it's 1 kilogram per liter for water. Water is so nice to work with. Which means that the mass of all that water is 113.6 kilograms. Well, that's significant. That's pretty heavy. I'm glad the floor was well structured underneath my tub. Okay, so we have the mass. C. Okay, C of water. I want you to stop right now and go look up, just Google specific heat of water. See what you get. Give it a try. What you see is all sorts of different numbers, all sorts of different units. What we're going to use for this one, well, I have kilograms, and I'm going to need degrees C. So I want something involving kilograms and degrees C. The number that I'm going to use, 4.186 joules per kilogram degree C. 4,186 joules, and heat is related to energy, per kilogram per 1 degree change in temperature. A lot of times we're going to be using calories and grams, and this number is a nice 1. Again, I love working with water. Lots of 1s. Okay, so what do we have? We need QM, we have M, we have C, we need delta T, but it's not 4. Fahrenheit. Okay, so 100 degrees Fahrenheit we need to convert, and 104 degrees Fahrenheit we need to convert. I just do these in Google. That's what I do, and feel free to do them when you're doing your practice problems, even on an assessment. If it's just a unit conversion, just do it in Google if you want. That's fine. So 100 degrees C, 100 degrees F. 37.78 degrees C, and 104 degrees Fahrenheit is 40 degrees C. Okay, so my delta T is 2.22. Good, 2.22 degrees C. All right, so that's my change in temperature. Did I get that right? 37.78. Yep. Okay, so let's calculate the heat. The mass was 113.6 kilograms. My specific heat is 4,186 joules per kilogram degree C. And my change in temp is 222 degrees C. Oh, going off the side there. Grab your calculator, give it a try. What do you get? What I got when I did this, it's a very big number. I got, really big, 1.06 times 10 to the 6th joules of heat. That's how much energy, heat energy, it would take to raise my bathtub water from 100 to 104 degrees Fahrenheit. Now, what is that number? How much does that really mean? So we can convert this to other units. And in order to use something that is a little more reasonable for you to figure out, I'm going to talk about calories. All right, So we talk about calories as another unit of heat energy. And 1 calorie, oops, is equal to that number that I just erased, 4.186 joules. And when we talk about calories, that actually is different than the calories that you see on a nutrition label on some food. 1 food calorie with a capital C is actually 1,000 little calories. So if you take this number of joules and do the conversion to little calories, what do you get? So the heat to heat my bathtub water is 252,192 calories. How many food calories is that? Well, divide by 1,000, 252 big C calories. What's 250 calories? That's not a lot of food, is it? But we're very good at burning that. So this is a lot of energy. This is a significant amount of energy. I mean, to change the heat of that much water is big. It's big. Most of what we're going to be doing is smaller amounts of calories. And calories is my preferred unit, so most of the problems I'm going to be giving you will use calories and grams and degrees C. So just keep that in mind. Some of them will use kilograms and Kelvin and joules. I'll mix it up a little bit, but in general I prefer calories and grams because the specific heat of water in calories per gram is 1 versus that 4,200 or 186 number. 1 is such a nice number to deal with. All right, so that's just the basics of solving for the heat needed to warm up a bathtub of water. Turns out it's a lot. Good job for watching.